Welcome back, my dear students. Let us continue with the last topic from the chapter Carbon and its Compounds, and the topic is chain, branches and rings. Although this topic is not very important, there is a subtopic inside this topic, that is isomerism, and we are expecting a short question from this topic, that is isomerism. To understand about isomerism, you need to also understand what are chain, branches and rings, which involve carbon atoms. So I'm going to mark this topic as a very important topic because you can have a question on isomerism that is going to use or utilize your knowledge about hydrocarbons, their molecular formula, electron dot structure, as well as the homologous series. So without wasting any time, let's begin. Now this is a direct question. The probability of it being asked is quite less. What is isomerism / structural isomerism? You don't have to be concerned or get confused. In your course, only one type of isomerism is there, and that is structural isomerism. So whatever is the definition of structural isomerism, the same remains for isomerism and vice versa. There are different types of isomerism about which you're going to study only in your higher classes. Explain with an example, or you might have a direct question, what are isomers? Isomerism is the phenomena, isomers are the compounds. So what are isomers or structural isomers? Explain with an example. To answer this, let's talk about what are isomers. It says compounds having the same molecular formula. That means you have two compounds, let's say A and B. Their molecular formula is same. Let's say C4H10. This also has the same molecular formula C4H10, but they differ in their structures. That means the way the atoms are bonded. For example, in this case, let's say in A, we have carbon bonded like this. And in B, the carbons are bonded, let's say, like this. Now there is a branch here and this is straight chain. I'm going to tell about what are chains and branches a little while from now. So what they say is, look at this. The way atoms are arranged are different. So they have different structure but same molecular formula. Let me complete all the valencies: CH3, CH2, CH2, CH3. So it comes down to C4H10. Here again CH3, CH, CH3, CH3. Fine, C4H10. So both A and B have similar molecular formula but different structures, and they are known as isomers or structural isomers since they differ in the structures. And the phenomena is known as isomerism or structural isomerism. Clear? Now, before we move on to how to write down the isomers for a given molecular formula or a given compound, we need to understand chains, branches and rings with carbon atom. Although this is a small topic and you are not expecting questions from here, but yes, from here we'll talk about one family called as cycloalkanes. And there is one question from cycloalkanes in your NCERT. So we'll quickly understand what are chain, branches and rings. So let us begin with chains or straight chain. Suppose your carbon is arranged like this. The atoms of carbon are arranged like this. We say they are arranged in straight chain or they are a continuous chain. What does that mean? The carbon is bonded to, if your carbon is bonded to two more carbon atom, not more than two carbon atom, we say it is in a chain format. Fine. Look here. If I number them, let's say 1, 2, 3, 4, 5, and I'm following a path. I'm just going in a straight line. There's just one route. There are no bifurcations. I'm not finding anywhere two routes. I'm not finding two paths to move around. So we say if a carbon is bonded to two more carbon atom, not more than two more carbon atom, that means it is arranged in a chain. Let's understand what do you mean by branches. If your carbon is attached to more than two carbon atoms, let's say one here, two here and three here, or 1, 2, 3 and 4. I'm just looking at this carbon atom. Look, if I have a compound in which a carbon is bonded to three or more carbon atoms, here 1, 2, 3, here 1, 2, 3 and 4. I say it is a branched carbon compound. Why so? I'm just now moving in a straight line. My straight path. Now suppose I am walking in a path. I'm just going like this. Fine. let's say 1, 2, 3. Can I say at point number 2, I have two paths, one going like this and the other going like this. So you are having branching. Similarly here, I want to go straight like this, but I see I have one root here and one root here. As I move from first carbon to second carbon to third carbon, at 2, I can go this side, I can go that side. We have branches. So these are called branching. One common mistake students do is, let me give an example. Suppose I draw something like this. Let me number them also. Let's say 1, 2, 3, 4, 5. Now you have a choice. Either you can number it from left to right or right to left. All these rules you're going to study in your higher classes. Fine. Now the same compound, let's say like this. And I'm going to fulfill or satisfy its valency also. CH3, CH2, CH2, carbon has a valency of 4. So I've satisfied all of them. What if I write something like this? Again CH3, CH2, CH2, CH2 and CH3. Are A and B the same compound or different compound? At one go students say no, this B is branched. No, my dear student. Chain means continuous carbon chain. See, you start walking, start numbering them. 1, 2, 3, 4, 5. A and B are similar compounds. It's just a bent over here. I can just pull it straight here. I'll get something similar to this. So both A and B are same compound. You have to look for longest possible carbon chain. There's no branch, just continuous carbon chain. Just number them, you will not falter. 1, 2, 3, 4, 5. I have no other way. Here also 1, 2, 3, 4, 5. It's a 5 carbon chain. Straight chain we can say. You just need to pull it up and it will be straight. But if in case I write like this, 1, 2, 3, 4 and 5. Fine. I have CH3 here, CH2 here, CH, CH3 and CH3. Right? Let me number 1, 2, 3, 4. You can number it like this. If a student wants, he can number it as 1, 2, 3, 4. When you move to higher classes, you will see the correct way is 1, 2, 3 and 4. Either left to right, you can go like this, like this. So this would be the correct way. In that complication, we are not going. Just see, now you have a branch at 3 because this carbon atom is attached to more than 2 carbon atoms. You have 3 carbon atoms. So you have a branch and this is the branched carbon compound. I'm telling you this because we are going to do one board question from here at towards the end of the video. The question will ask, draw the branched isomer. So you should know what exactly is a branched. Coming on to the last part, rings. Now for rings to happen, rings are what? Closed structure. If you want the simplest possible closed structure, how many minimum points you should have? 3. That means you should have 3 carbon atom as minimum so that you can get a closed structure also called as ring. Let me satisfy the valency. CH2, CH2 and CH2. So this becomes C3H6. Now look at this C3H6. Can I say this point is very, very important? Again, we are going to use it in the last question of this video, which is also a question given in your sample question paper released by CBSE 2022 in just the recent ones. All right, C3H6. Now, is this formula not similar to CnH2n? And this is the general formula for the alkene family. I'm also telling you this CnH2n is the general formula for cycloalkanes. Cycloalkanes. Remember that. Now look, C3. What is the word root for 3 carbon atom? Prop. In this chain, you can only see carbon-carbon single bond. So obviously, the suffix is a propane. But you know that propane belongs to the family of alkanes. And alkanes have general formula CnH2n plus 2, where n is greater than equal to 1. So prop means 3 carbon atoms. So the propane should have formula C3H8. But I have formula C3H6. Why? Because this is not propane. You're going to add a prefix cyclopropane because of the cyclic structure. This P will become smaller. First alphabet capital then. Because of the cyclic structure, this is not propane. It is cyclopropane. Similarly, this one is your cyclobutane. CH2 CH2, CH2 and CH2. The formula is C4H8, which is similar to the general formula of the cycloalkanes. So they're going to be cyclic closed structures and have carbon-carbon single bond. And I've told you in my last video, if you have carbon-carbon single bond, we call such compounds as saturated hydrocarbons. They're made up of only hydrogen and carbon, and they only possess carbon-carbon single bond, so it is saturated hydrocarbons. So this point is important. We are going to use this in the next question. Now we can also have unsaturated cyclic compounds. The details are not too much in your course. You only need to remember, say, a structure, hexagon. These are double bond alternate. That means here you have double bond, then single bond, then double bond, single bond, double bond, single bond. So you have alternate double and single bond. Fine. This step you have carbon, CH, 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 CH. This is known as benzene. Its structure is there in NCERT, so I'm telling you this is benzene. Aromatic hydrocarbon, all aromatic you're going to study in higher classes. This is called benzene. The formula is C6H6. 6 carbon and 6 hydrogen. Since you have carbon-carbon double bond, it's benzene. It is an unsaturated hydrocarbon. So it's called as unsaturated hydrocarbon. You should remember the structure of benzene. They might ask you draw the electron dot structure of benzene. You should be able to draw it. Fine. So this was all about chains, branches and rings. We are going to use this concept now in solving the subsequent questions. So let's begin with the next question. What will be the formula and electron dot structure of cyclopentane? So you cannot say that this question is not there in the syllabus. It is your NCERT in-text question. Cyclopentane belong to the family of cycloalkanes. Fine. And I told you what is the general formula? CnH2n. Fine. And you will only have carbon-carbon single bond because you have ane, alkene, saturated hydrocarbon. Pent means you have 5 carbon atom. Substitute in the formula, we have C5H10. It is cyclo, so you're supposed to draw a pentagon, something like this: CH2, 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 here CH2 and CH2. Fine. You have to convert into electron dot structure, so all the bonds is supposed to show as electrons. C1, 2, 3, 4. Fine. Another 1, 2, let's say 3 and 4. For this carbon, 1, 2, 3 and 4. This carbon, 1, 2, 3, 4. And finally this carbon, 1, 2, 3 and 4. Fine. Now I'm going to show hydrogen by red. So this is hydrogen. These are again hydrogen. Again a hydrogen here. A hydrogen here. Every carbon has 2 hydrogen. That I'm going to show like this. Alright, so you need to convert this into dots and crosses or simply dots, right? So you'll be now able to do even this question, cyclopentane. If they ask you cyclobutane, you know it is C4H8, cyclopropane, C3H6. Fine. You cannot have cycloethane or cyclomethane. Why? Because for a closed structure, you have to have at minimum of 3 carbon atom. So I can write here N greater than equal to 3 for cycloalkenes, right? Let's move on to the next question. Draw the electron dot structure for the possible isomers of butanes. We are expecting such questions. Fine. First of all, you should know to which family does butane belongs to. What is its molecular formula? Then you should know the electron dot structure of whose isomers. So this kind of question is utilizing most of the concept of the chapter. Your hydrocarbon knowledge, the molecular formula, electron dot structure and the concept of isomerism. First of all, butane. Just look at the name. Split it. Ane means it belongs to the alkane family with the formula CnH2n plus 2. Fine. But means 4 carbon atoms. C4. You should be able to write down the formula correctly. C4H10. Now you need to check whether the isomers are possible or not. First we'll draw the isomers, then we'll convert them into electron dot structure. So first is 4 carbon atom 1. You can just draw the skeleton first of all. One possibility is this. Just the skeleton means I have not satisfied the valency of carbon with hydrogen. Fine. Now let me do it like this. So I have 10 hydrogen and I am satisfying the valency of carbon with hydrogens and we have C4H10. So let me number them for ease, either from left to right or right to left. Let's stick to left to right until and unless you move to higher classes. 1, 2, 3, 4. So the formula is C4H10. We have checked that. Let's look for any other combination. This is number 1. Let's see if we have any other combination. 1, 2, 3 and 4. My dear student, if you write like this, it is not a branch, because look, 1, 2, 3, 4. This carbon is attached to only 2 other carbon. It is a straight chain. This one and this one are same. Fine. Let's look at the possibility. I have 1, 2, 3 carbon. I changed the position of 4th carbon. When I moved it here, this and this resemble. They're the same. I'm going to move it at the 2nd carbon atom. 1, 2 and 3. Then satisfy the valency of carbon. CH3, CH, CH3 and CH3. 3, 3, 6, 3, 9 and 1, 10. So the formula is C4H10. Yes. Both the structures are different. This one is a branched one. This is straight chain. This is chain. This is branch. That is why I taught you the concept of chain branches. Alright. Let's look at any other possibility. Now 1, 2, 3. If I put the 4th one here, then this and this are same. Alright. So no other possibility. So we have 2 isomers. So draw the electron dot structures for the possible isomers of butane. I am sure you can convert them into dots now. You can obviously convert into dots and crosses and write down the electron dot structure of the possible isomers. If in exam it's asked how many isomers are there, you don't have to draw, just draw in rough the skeleton and then write down 2 possible isomers. Let's move to the next question. Now this question is partly there in NCERT, and then I have rephrased it and added another portion. Are structural isomers possible for bromopentane? Now my dear students, first of all we should know what exactly is bromopentane, and then we need to write down its formula. After we write down the formula, we should know, or we will find out whether isomers are possible or not. And if possible, we are supposed to draw the electron dot structures for the same. So let's talk about what is bromopentane. Let me quickly explain this. If you have pentane, just look at pentane. Don't panic by looking at the question thinking that you've not done this. Let's say you've talked about alkanes, pentane. Pentane means alkane having general formula CnH2n plus 2. Pent means 5 carbon atom. So your formula is 12. C5H12 is the formula of pentane. Now suppose I knock out one hydrogen and attach bromine. What do I get? C5H11Br. Now this was pentane and this is having 5 carbon atoms, so pent. Again it has all single bond ane, and this is your halogens. You must have studied in your chapter number 5. Halogens are fluorine, chlorine, bromine, iodine. They are functional groups which are having a prefix, one that is attached before the word root. The prefix is halo. Halo like fluoro, chloro, bromo, iodo. Since it is Br, bromo, prefix means to add before the word root. Bromopentane. So you know pentane, substitute one hydrogen by functional group bromine. Right? We do not use the word bromine, we use the word halo. Halo means it could be fluoro, chloro, bromo, iodo depending on which halogen you are substituting. And you get bromopentane. So the formula is C5H11Br. Now let us see whether or not the structural isomers are possible for bromopentane. So we have C5H11Br. Let's start drawing. The first one, straight chain, 1, 2, the way you would have drawn for pentane, 3, 4, 5. Okay, I'll number them also, 1, 2, 3, 4, 5. CH3, CH2, 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 CH3, right? I'm going to remove one hydrogen and put over here bromine. That's the first possible isomers. You can draw electron dot structures yourself that I've already taught you. Convert the bonds into dots and crosses. This is the first possibility. Now, since Br is the functional group, we'll change its position. Let's see what happens. It is at this position, right? 1, 2, 3, 4. Let me begin. That's 5. Let me put it at this position. Let's say begin from this side, Br. If I would have put it over here, it would resemble the first one, right? So we have CH3, CH, CH2, CH2, CH3. Now I have put it at carbon number 2. That's a possibility, number 2. So 2 isomers. Just count whether they have the same formula. 3, 4, 5, 6, 7, 8, 9, 10, 11. So C5H11 and Br. Same molecular formula, different structure, so they are possible isomers. You convert into electron dot structures, alright? Now let's move this bromine to third carbon atom. So 1, 2, 3, 4, sorry, this is Br, 4 and 5. Again CH3, CH2, CH, CH2 and CH3. Now bromine is attached to the third carbon atom. So all these three structures are different. So we have 3. Look for any of the possibilities. If I take it to fourth one, let's say like this 1, 2, 3, 4, 5 and I put it over here, right? Then the numbering, if I do from here 1, 2, 3, 4, 5, at second carbon I have bromine. Look here, at second carbon I have bromine. So the structures will be same. So this is not an isomer. So these are the 3 possible isomers of bromopentane. You are supposed to convert them into electron dot structures. Alright, let's move to the next question. Now this is the question which is present in your sample question paper released by CBSE in the year 2022. Fine, this is the latest sample paper and this question is given in CBSE sample paper. So this one you should be able to do. There is one common mistake that most of the students are going to do if they do not remember one concept that I've already told you earlier about cycloalkanes. Let's see how. I'm going to mark this question as very, very important because it utilizes so many concepts from the chapter. How many isomers, so isomerisms we're going to talk about, are possible for the compound with the molecular formula C4H8? You have C4H8, right? Draw the electron dot structure, so the concept of electron dot structure of the branched chain isomer. Remember the branched chain isomer, now you should know what you mean by branched chain isomer. Clear? I've already explained you a little while ago. So let's begin with C4H8. I've told you C4H8. First find out which family it belongs to. It has a general formula CnH2n. Right? Okay. Now since it has formula CnH2n, right, it belongs to alkenes. That's the first thing that comes to mind. And if it is alkene, you have to have what? Carbon-carbon double bond. At least one carbon-carbon double bond has to be there when you draw the structure of C4H8. Now, I've also said that CnH2n is also the formula of cycloalkanes. So we're going to draw a closed structure also. Since it is alkene, it will have only carbon-carbon single bond. So let's start drawing the structure. But before that, let me name this C4H8. If I'm taking it from alkene family, 4 carbon means but. Since it is alkene, Ene, it is butene. And it has to have one carbon-carbon double bond. Let's write down the first structure. 1, 2, 3, 4. And I put, let me number them, 1, 2, 3, 4. And I put the double bond here. Let me balance or satisfy the valency. 1, 2, 3, 4. Like this. CH, CH2 and CH3. Just keep checking the molecular formula. 3 plus 2, 5, 6, 7, 8. So it has C4H8 formula and it is called as butene. It's basically called as but1ene. That nomenclature is not there in your course, so I'll just leave it. This is the first structure. Let's see what is the possibility. Since double bond is the functional group, I can change the position of double bond here. So the second option is 1, 2, double bond, 3, 4. And let me just satisfy the valencies of carbon, CH3, CH, CH and CH3. So 1, 2, 3, 4. Now double bond is between carbon 2 and 3. Here the double bond is between 1 and 2. So both of them, though they have the same formula, it is also C4, 3 plus 1, 4, 5, 6, 7, 8, C4H8. They have the same molecular formula but different structure. So they are structural isomers or simply isomers. So 2 possibility. Let's see, they're saying branch chain isomer. So let's try now a branched one. 1, 2, 3 and I put the double bond here. So you see that this carbon is attached to more than 2 carbon atom, 1, 2 and 3. So obviously it's a branch here. Let me satisfy the valencies with hydrogen, CH3, CH3 and CH2. Because 2 double bond is there, 2 plus 2, 4 valencies satisfied. Now the formula is again C4H8, right? So if we go like this, 1, 2, 3 in correct order, the rule says we have to name like this: 1, 2, and 3. All right, this will leave. How I number them as 1, 2, 3 later on. It's not for you to understand it right now. Okay, so we see that we have branched. You are supposed to draw the electron dot structure only for this one. So you can try this in rough, and only this one you are supposed to draw the electron dot structure. But you have to keep trying. Is there any other possibility? Because the first part, how many isomers are possible? Most of the students will say 3 isomers are possible. No, my dear student, you also can have C4H8 as cyclobutane. This CH2, CH2, CH2 and CH2. 4 carbon and 8 hydrogen arranged in cyclic form. Arrangement is different. So even this is a isomer. They've only asked you how many isomers. So half a mark for writing how many isomers. Board doesn't have 1/4 and 3/4 marks. And the next part is draw the electron dot structure of the branch in isomer. Of drawing this structure in the form of electron dot structure by dots and crosses, you get 1 mark. Because another part is also there, the question, but that is different one that I'm going to take up later on. So this is an important question because this is the point where most of the students falter. My dear student, with this question, I not only come to the end of this video, but also to the end of all the question answer sessions from chapter 4, that is carbon and its compounds. I'm going to take up questions from the recent sample paper released by CBSE. They might look same as discussed in my previous videos, or they might be different. We'll quickly finish up all those questions, and that will be the completion of the entire chapter, carbon and its compound. So stay tuned for my next video. Keep watching my channel, and if in case you like this session, please like and subscribe to my channel. Thank you so much.